Okay, now what we've done is we've laid the frame on its side, and I've already cookbook style here, I went ahead and shimmed the way the frame is laying so that it's laying basically as parallel to the earth as I can get it. What I mean by that is, not that you can trust this, but is the backbone level to the earth? In this position, it's very, very close. Are the bottom rails parallel to the earth or level to the earth? In this position, it's real, real close. Not that that's the most important indicator, but what you're trying to do is get an idea, is this basically what the builder of the frame considered to be laying on its side, perfectly on its side, okay? But more importantly, for basis of comparison to the measurements of level we took previously, what we're going to do is make sure that the front motor mount is at 90 degrees, okay? Big T, if you want to swing around and show them that we're 0.05 of a degree from 90 for all practical purposes. The motor mount is sitting dead vertical to the earth, dead perpendicular to the level of the earth, okay? What we want to do in this test is figure out, okay, the plane of the neck, once again, irregardless of the rake, we don't give a shit about the rake, but is the plane of the neck 90 degrees or perpendicular to the plane of the front motor mount? We already know the relationship of all the other mounts to the front motor mount. They're out by about 0.6 degrees, getting worse as you go back. Okay, we already know that, but how is the neck versus the front motor mount? We figure out how the neck's doing versus the front motor mount, and we can figure out how all the other mount points are as far as in plane goes. Okay, so we've got the front motor mount sitting at 90. I just put a fairly heavy rod that's approximately the diameter of the neck through hole in here, just so I'm not checking the flatness of the outside of the neck, which could be imprecise. I'm checking to see, okay, how does the stem of the fork go through this thing, okay? We will just put a level on here just to see for the hell of it. If you just lay one across the flat of the number boss, it's 89.3. So right there, assuming that number boss is really flat, which I'm not going to trust because it's got paint on it and it's not machined off for that purpose. But right there we're showing 0.7 degrees off from perfect squareness of plane perpendicularness, okay? Looking at the rod itself, we're getting close to 1 whole degree. It's about, flipping the level the other direction, it's about 0.7 degrees out of perpendicular to the front motor mount. Okay, so what's all this bullshit mean? What's all this technical jargon mean as far as can you use this frame to build a chopper or not? Okay? If you're a perfectionist, the answer is hell no. Because if you're a perfectionist, you ain't going to use anything that ain't perfect. So I'm not going to debate that with you. If you're on a budget, could you use this frame? In my less than humble opinion, yeah. Because of the existence of shims. Now that we know what we know about the out of planeness of the mounts as we come backwards, we're already going to be on guard knowing that what we're going to need to do is shim to bring everything back into plane. It's rare that you get a frame that's so perfectly designed and built that there's not a little bit of shimming necessary to get the powertrain in perfect plane. Which, if a lot of you guys run belt drives, the more perfect a plane all the powertrain is, the better that belt drive is going to last, the less it's going to get its sides eaten out, the less of all the problems. So you do want to take your time and get your powertrain dead square, dead level, dead in plane, dead in alignment. That is worthwhile, so don't take the wrong point away from this. But when we're talking half a degree, 0.6 degrees out of plane, you could easily shim to get the powertrain in alignment. What I mean is the transmission in same plane as the motor. In other words, you don't have this number going on. Okay? You could easily shim either these bolt holes or these bolt holes and get the powertrain in plane. Okay? Back here, where, if I recall correctly, this axle plate was slightly higher. When you look closely at this axle plate, it was really cheaply cut out, probably with some kind of CNC plasma or some kind of plasma cutter. It's rough as hell anyway. It needs sanded anyway. So a guy could bring the axle into plane with the front motor mount just by grinding this bottom edge of the axle plate slot. You could probably quite easily bring the axle into plane.